there's also a little round bit here, as you notice, which is the other half of an anticline, which means that you have an oil field right where you're standing. Actually, some of the wells are right behind you, nodding donkeys. And there's a historical significance through past on the right-hand side as we're going up. The famous Edward's Trace, famous mostly for its by its flanking marijuana fields, I think. Anyway, so it's a coincidence then that this Lagon Bouf mud volcano is on the Martel main fault. There are a couple on the Martel main fault. There's another one I think further in. I have never visited it. Okay, highest point in southern Trinidad, Trinity Hills. And this is the Gromont Formation mostly, okay, for all of this stuff. The Gromont Formation sits under the Mayaro Formation, which is in turn overlain by the Palmiste Formation in this area. The Palmiste Formation is the green stuff. The Mayaro, the light green, sorry, the Mayaro being mostly the dark green and the Gromont being the dark blue. So there's a big syncline here. On this nose of this anticline, which is the Lizard's anticline, you have the Goudron, the Navette field. The Goudron field is an extraordinary field and it sits right up in this little cusp. It's the only bilateral synclinal play that I know of that's actually written about in the geology, in the field, in conference proceedings. Mud diapirs along crests of structures and along wrench faults are quite common in Trinidad. And as we will see, the Marcel main fault, I have mapped it myself in detail on this point. And if you look at a cross-section through this field, right here, I don't know if you can see that, but here are the two flanks of the structure. The Martel main fault is in the middle, and inside of that they just call it a fault complex. We were just walking the section here, and you can see remnants of that fault complex trending out towards Gyayaguayare Point. And by a fault complex, if you map it in detail, all it means is that there are a number of faults, mishmashing the section to smaller units, and I have maps of that if you're interested in them. So in this field you have quite an interesting combination of very shallow Naparima Hill. You can see here the section, the lower tertiary section is extraordinarily thin, and then you have these Gromont sands, which is this formation, as I said, on both sides of the structure, and those are the oil reservoirs. There's not a lot of millions of barrels in these, but there are a few million barrels all the same. This is a map of the deep structure, and you can see that this nose mimics exactly what you see in the surface geology. You can see that this nose mimics exactly what you can see in the surface geology over here. And the core of it is an extension of the Lagon Bouf mud volcano. So whether it's fluidization of this core complex that's causing the mud volcano to occur there, or some other phenomenon releasing liquids from deep down that come up the fault plane to allow the mud volcanoes to form here. Okay, mud volcanoes, radix, all of these major trends in Trinidad have mud volcanoes along them, and as you know, the northern part of the Nariva fault belt has lots and lots as well. So that's basically what I wanted to talk to you about from a geological perspective. When you go further offshore, in the deep water, I have some examples of mud volcanoes that were published in the last conference we had here, and I brought some pickies so that parts of that publication, so you can see why mud volcanoes can be interesting from a petroleum trapping point of view and from their effect on local sedimentation. I hope this is quite clear. I tried to enlarge these maybe to the point where they're too big, but I did it all the same. So let's start with this one. So this is in the deep offshore. And here you can clearly see that the seismetics has picked up all the beds on the flank. So here's mud volcano number 1, mud volcano number 2. So you've got two mud volcanoes infringing on each other. And you can see that they have caused the sedimentary succession to be modified by their presence. So mud volcanoes laterally cause potential stratigraphic pinch-outs and potential fairways for the sands to be preferentially deposited. We will see some examples of mud flows today, and in seismic we believe that they look like these sorts of things. You see this squiggly stuff that's in here? You think those may be actually what Kugler called tacites. Same thing here. You see this mud volcano comes up to the surface and you see these pile up. When you're looking for traps on the flanks of these things, they may be associated with just the mud itself being a seal and the sands coming out and abutting. In one example here, there's an added nuance which is quite interesting. An example in that if you look at the shape of this one carefully, you can see that there is a nose that sticks out here like a bump. And underneath that, of course, you have the opportunity to trap hydrocarbons in an interesting way as well. So, you know, when we look at these things at the surface and we think, oh, they're interesting little surface features, we should really think about the number and the variety of ways in which you can find these things in traps adjacent to these things. This one has an interesting feature. You see this collapsing rim? It's quite common with these that secondary flows will cause the flanks to collapse. And that's what you see, or what it looks like you see in the forest reserve field. That's the one I have an example here. So in forest reserve, according to the literature, again, they have these interesting collapse features on the sides, which set up their own anticline. And here you see the influence that it's had on the thinning of this package, maybe, or the thinning, but certainly uplift later on of those packages, and potential seals adjacent to them, you know, in these areas. So it's an interesting phenomenon. Just look at them at the surface and say, wow, that's a mud volcano. I think it's even more interesting to think about what their real geometry might be in the subsurface in order to understand the traps that are associated with them. And they're very complicated traps, particularly in the way we conventionally do exploration, because you pick a horizon, you map it, but that may not be the horizon that's trapping. Yeah? So you have to actually work backwards in this case. You have to say, what is trapping? Then I need to map that horizon around.
No, just extreme stratigraphy.
So I thought I'd show you some of these just to give you a feel for what we see in these. On this map here, you've got Beach Field, Woodron here, Phillip, Navet Field, Mayaro that you just passed through. And again, we're looking at the core complex of the Marcel main fault as it extends inland to we don't know where. Just like I don't understand what happens to Los Bajos Fault because it's not seen offshore. It gets to here and we don't even think it goes there, and then disappears. We have a similar phenomenon on this side. I did bring something that shows what the plate motions are doing, and I don't know